the first thing that I would do, since velocities are given, is I would graph the velocity versus time graph. So the time is going to be on the x-axis, and it's going to be in seconds, and the velocity is going to be on the y-axis, and it's going to be in meters per second. Okay? And we need to look at the problem and see the different velocities that are represented so we can figure out what our intervals are going to be. How are we going to label our axes with numbers? So she starts out with a velocity of 1.5, then she slows to a velocity of 0.5, and then she travels at a velocity of 1 meter per second, but it's in the opposite direction, so it's -1. And so we have to represent a velocity, a difference of -1 to 1.5, which is a total of 2.5 difference. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 intervals in which to represent that. And so if you take your calculator and you divide 2.5 into 16 intervals, what do you get? 2.5 divided by 16. What'd you get? 0.15625. So 0.15625. Okay. Now, that we got to round up to the nearest 1, 2, or 5, according to our laying the foundation rule. So we round up to 0.2. So each one of our intervals is going to be 0.2. Okay? Now, in order to capture -1, you got to start at -1. Yes?
So you have to go by 0.2 because you divide it?
You don't have to. But this is a method that you can use to help you to figure out what a good increment would be. Okay? A good even increment. Good even increments are going to be 1s, 2s, or 5s. Okay? Okay. That's just kind of a big space. You probably ended up not using most of your graph.
Yeah.
Okay. If you go by 0.2s, you're going to use more of your graph. But that's okay. All right, so I'm going to start at -1. Then it's going to be -0.8, -0.6, -0.4, -0.2, 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, and 2. Okay? Now my time, I need to just add up the time. So she travels for 2 seconds first, then she travels for 4 seconds, so that's 6 seconds, and then she travels for 7 seconds, that's 13 seconds. And so probably we're going to number by ones. Let's count it though. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to count by ones. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So then we're going to plot this. So first of all, we're going to plot 1.5 for 2 seconds. So here's 1.4, here's 1.6. So halfway between is 1.5. And that's for 2 seconds. Then she travels at 0.5 meters per second for 4 seconds. So here is 0.4 and here's 0.6. So halfway between is 0.5 right here. And that's for an additional 4 seconds. 1, 2, 3, 4. And then she travels at -1 for 7 seconds. So -1 is down here, and it's for 7, so that would take us to 13. And then we're going to go ahead and draw our lines representing our velocities. These are different line segments that are constant motion line segments. And then there's some dashed lines representing the this vertical asymptotes, that the change in the velocity. Okay, so that's our velocity versus time, and you can write that v versus t on the graph. And then we're going to use this graph to figure out our position versus time graph. Now, it doesn't say where Tiffany starts. It doesn't say what the origin is. Okay? But we know that we can figure out the displacements, which is the change in position, by using the area. So the area of a velocity versus time graph is the displacement. So the displacement from 0 to 2 seconds is going to be this area of this rectangle here. And the change in the displacement from 2 to 6 seconds is going to be the area of this rectangle. Okay? You know what? Let me, I messed up here. Did you see where I messed up? I messed up because I went below the x-axis. So what I said was true, but I was drawing this as if 0 is down at the bottom, and it's not. Here's the origin right here, and so this area only goes down to the origin. Okay, and then this is a negative area. It goes between -1 and 0. Okay? So that change in displacement is in the negative direction. So here she is going in the positive direction away from the office, and then here she's going in the negative direction toward the office. Okay? So what I want to do is I want to find those areas. And I'm going to do that just on another piece of paper. So I'm going to label this delta D1. This one's going to be delta D2, and this one's going to be delta D3. And delta D1 is the area of rectangle 1. And that's just equal to the height, which is 0 to 1.5. So that difference, 1.5 minus 0, is 1.5, multiplied by the time interval, which is 2 seconds. And that is 3 meters. Right? It's kind of obvious, right? Velocity multiplied by time is distance. So velocity multiplied by time interval is the change in the position or the displacement. Question?
No, I was just saying how that's how the formula is. The velocity equals meters divided by seconds.
Right. Yeah. V is equal to delta D divided by delta T. And what this is a rearrangement of that. If you multiply both sides by delta T, you get delta D equals V times delta T. Right? And so that's really what we're doing. This is the area right here. Okay, delta D2 is also equal to an area, and it's equal to 0.5 times the delta T, which is 4 seconds. And so that is another 2 meters. And then delta D3 is -1 multiplied by 7. which is negative 7 meters. Okay? So we get a picture of what's happening. Right? The person is going to go forward 2 meters from their starting position, and then they're going to go forward another 3 meters, and then they're going to go back negative 7 meters. So we have 2 and 3 is 5, and then back 7. Where do we end up? If we start at 0, we end up where? At where? At negative 2. Right, because we go forward 2 and then 3, that's 5. And then we go back negative 7, we end up at negative 2. That's one way of graphing it. Start at 0, and then we end up at negative 2. Now, apparently, the office is at negative 2. Or maybe it's even further past, because she was going back to the office. So we could say, what if we put the origin at negative 2? That means she would start at 2, go forward 5, and come back negative 7, and she'd be back at 0. So you have a choice, because you don't know where she started. Okay? I'm going to start at 0. That just seems like an easier thing. But I know that I have to put on my graph negative 2, and I have to represent 3. That's my smallest and my biggest number. Okay? So negative 2 and 3, the total is 5. Yes? Yes. You could start at 2 and end at 0. Yes. So I'm going to go ahead and start at 0, but you could definitely do that. Wherever you start, you're going to end up 2 less than that. So we need to know about the intervals. So I have to, these are not positions. These are changes in position. So if I start somewhere at 0, I'm going to get to a maximum displacement from 0 of 3. And then when I go backwards, I'm going to go back to negative 2. And so that's a difference of 5. Now, we have to represent this on the graph. So there's 16 spaces we've already counted. If we divide 5 by 16, what do you get? What do you get? Around 0.3 something, right? It's about 1/3. So it's about 1/3, right? And that is about 0.333, right? That means we have to round up to 0.5, right? Because we're always going to round up to the nearest 1, 2, or 5. Okay, so we need to represent negative 2. I do, at least. I need to represent negative 2. And so I'm going to represent negative 2, negative 1.5, negative 1, negative 0.5, 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. I'm going to stop there because I've covered everything. Let's see, no. And we got to go to 5, don't we? 4, 4.5, 5, 5.5. Okay, I'll stop there. Okay, so then time is the same on both graphs. And this is time. It's in seconds. And this is position or displacement. It's in meters. Probably more appropriate to put displacement because we don't know exactly what the position is. We're just deciding what it's going to be. We're going to say that the office is at negative 2 and the starting point is at 0. So we're going to start at 0. And then according to this, we move to 3. And we do that in 2 seconds. Then we go to 2 more, which is 5, and we do that in 4 seconds. And then in 7 more seconds, we go back -7. And if you go back -7 and you're at 5, you end up at -2. So we end up here. Okay, and then we're going to draw our trends. And these trends represent the velocities that we've already graphed. Remember, the slope of a position versus time graph is the velocity. Okay. And then this is going to be a P versus T graph.